Microphone. Hello, hello. Good evening, HiQ type. It's been a long while. Last time you were around, I was already working on this project, so that was a year ago. I hope you and everybody in chat is doing well. And we're going to get started very soon. I thought I was like, oh, I did what I can with this and I don't know how to make progress. And so I kind of moved on to another silly side project like I like to do on my spare time. I work by, I have an idea and then I think about that and only that for a while. That can be weeks, months. And, and I got a new idea about this. Actually, I got several new ideas because somewhere in 2020, I did find some literature on generating random models for SAT solvers that would avoid having to compile the entire model in the form of a BDD, and that was really costly because that's just too much work. I'm a bit lying. You have to compile but smaller parts. It's kind of clever, and I actually don't remember how to do this, but I took notes, so I know how to remember how to do it. And then I got a new idea, which was, let's generalize around along another axis, and be able to write full data log programs and use that as the source. And that's sort of what we've been doing. I didn't stream for like 6 weeks on this project. So that's only the third stream since I started in January 2021. Since last time I had a bit of fun with Nix. Hey Simon, how are you doing? So what did I do? I did a Nix shell with opam2nix to have a bit more reproducibility. It is not perfect, but it's serving me well. There's plenty of things I haven't done, like I haven't configured my Emacs to use LSP server by default, and I haven't fixed the type errors that we had because I forgot we had them. So we're going to start with fixing a couple of type errors, which I probably introduced by importing containers. So it's your fault, SQ. Where was I? And then yeah, I'm gonna I can show around a little what's already there and what's missing for recursion. The general idea is that we want to do data log with a finite number of atoms, so that we can actually implement recursion. I'll be there in a second. Data log. Right, so in the datalog.ml, it's in branch datalog, and I didn't push what I did yesterday, so let me push. We also have I moved the CI on GitHub Action so that it's a bit easier to access. Right, so I want to turn on LSP. And I have no idea what's happening here. Oh yeah, there's a couple of... No, actually that's not your fault, that's entirely mine. There's a couple of things called var. So that was supposed to be the var from where? There's only containers open? Well, it's called var, sorry. That's arg. I don't remember what this is about. I should show around a little so we have time to have a bit of a look. What's the type of pass? We don't know. Okay. So what do we have here? And we have a split screen, and we're going to see two parts. So we have a definition here of relational algebra, which is something that is that can be reduced to SAT or reduced to logic using. Like I use the code paper as my basis for this. I did that last time. I don't remember the details. Oh, that's the main function. I think, is it? Right, I compile everything to relations, and then and like relations are matrices, and then we compile the formula to a formula.t. A formula.t is that type that we see here. It's just you know, syntax. This is Emacs, yes. Emacs in 2021 can be pretty stylish. There's a few more things up my sleeves. The breadcrumb, yeah, it's actually made tons of progress in the past few months, I think. Like it used to be, and there's like I did spend a bit of time. This is not default Emacs. You have to download the icons. So I think there's a package called All the Icons that does that for you. Customizing Emacs these days is a pain. I guess if you start with Doom Emacs, it's much easier because it has better defaults. I've got some issues with it, and it's hard to like port an existing configuration to it, or at least I don't know how to do this. So that's the first part. It's about these relations, and then I have the data log part, which is out of the modules. I can just look for end. This is an excellent point. It's actually easier than it used to be, but there is so many things to do to get basically the default experience. Now, it's like you're not supposed to use vanilla Emacs at all. Doom Emacs is reasonable default, so I guess you would start there. I'm trying to find where the definition of programs is. Okay. I call it prog. Okay, so that's the type of program. There's a couple of things. Oh, that was these var. Okay, so we have this var and we have this var, I think, and that's where it's getting confused. So a program. What are these? That's the rules. The rules are data log rules normally. There's a list of relations that we consider to be the facts. So these rules define things that are not here, and the goal is like it's the goal of the data log program. It's what we need to have true. And our goal will be to iterate through these relations and find all possible instances of them which hold. But yes, Emacs customization is it's whatever. It requires a lot of time to get a good experience, and that's a problem. And there are some days where I just want to spend this time because I'm this sort of person, but really it's a bit silly. You have a question followed by possibly bad news. Ask the question and tell me the bad news. issue 20. Let me... Oh, depend on issue 20. Why is it? I don't know why it's still so big, but yes, I don't know how to solve issue 20. Yes. I still have no solution for issue 20, and yes, things are very complicated. I don't even know if I wrote everything. Like there's a couple of things, and I think there's more. Yes. So the thing that is really hard and that I never wrote down is that I think the thing that's really hard is that something that is not reachable logically doesn't mean it's not reachable without glitches. Like if you like I once made a synthetic example. I have like two items blocked by two keys and a key each in the same dungeon, and you have one of the key, and you can sort of switch and have only one of them, and that leads you to some places, and you can actually you can very easily soft lock the game if you're not careful about this. Issue 20 is a pain, and today and for a while I'm deciding to ignore it because I have no idea how to solve it, and I'd rather just have fun coding what I know how to solve for the moment. I have played a few dual randos. They're I did the Christmas special for this year, which did my head in quite a bit. It was a thing. There's at least one dungeon that made me crazy because I missed a door. Yes. Consumption of finite resource along a path. Because you have like a string of keys or something like this. Let me think. Yes. You light the torch. Each course there. Oh, oh, that is cute. If you don't have like if your logical access is, oh yeah, but you don't have anyway. So if you don't have half magic, even if you use the torch, this is really cute. Don't hesitate to write exactly this in the issue. This is fantastic. I love this. Yeah, I did the Christmas special is the only like cross dungeon door rando that I've done, so I haven't thought about it a lot. That's a delightful dilemma. I have no idea how to deal with this. But you can deal with it the same way as the multiplicities. Like you have that many shots at the rod, but it's a bit difficult to count. But you can sort of do that and then bind certain accesses to this. Yeah, whatever. Well, that's kind of nice though. You say, oh, that actually requires logically half magic or something like this, or a bottle. That's nice. So why are you unhappy? Did I open Relarg? I didn't. So index of. Maybe index of is the problem. No. That's an arg list. Oh, X maybe is the wrong thing. A sequence of crystal switches and only bombs to hit them. Whoa. Oh. I mean, you could do it, but there's not a lot of places where you can enter without the sword. Yeah, no, it sounds difficult, but yeah, you're right. Yeah, that's quite true. Oh, it says this is supposed to be an int because it's called pass. Yeah, what have I done? That's the problem with returning to something after a month. So I need to remember what's happening here. This looks actually fairly correct. Oh, equal. See, that was containers after all. Dascube, do you remember? Can you remind me? What is the? I feel I solved this before. Did I lose some things? There's a module in container that contains the generic equality. Which was it? Let's have a look. stdlib dot equal. Sure, that makes sense. I did that for compare before. Okay, I didn't lose any data. Yes, Emacs is fantastic. This is actually this is called Emacs Application Framework. It's a bit fresh. It's a bit fresh, but I've had trouble streaming with both an Emacs and a browser open in a separate window. I had a setup and it broke when OBS updated once, and I got tired. Like, we spent some time making EAF work. I don't remember what I said. What did I say was fantastic? So anyway, I don't use it in my normal workflow. It would require a lot of customization for me. It's just for streaming. It's quite convenient. Emacs is a bit obsessive. Yeah, I got Emacs is like Pinky in the brain. Sorry, in the cartoon. It's how to conquer the world, and that's pretty much it. Okay, so we fixed type errors like a church. Yeah, maybe. So the problem we have here is, there's something missing. Don't we need an environment at some point? I think I might have ignored rules altogether. Let's have a look. No, that's, my file is pretty big. I need to refactor this. I should totally have spent some time beforehand looking at my code. So we have rule throughout arg. We have a no. Let's go see the definition of rule. So literal, and a literal is here. A declaration together with arguments. That sounds pretty good. How do we deal with the root? Oh, we compile things as themselves, I guess. Right. Right, but that only works. That only works if the root is an instance root, like a base thing, because these one we want to see in the resulting program. But the rules that are defined, we just want to compile them as a condition. Let's just go there, and we have the type here. So that's an expression. It's part of a declaration. Yeah. And root is declaration. Yes. So declaration is just a name with an arity, right? We can have a look at this. So if I go there and I go there, oops. Right. So it's like in Prolog, I just said, yeah, you have a pair of a name and arity, and that defines an entity. You have the same name used with two arities. It's two different things. I think it's fair. So what we want, in addition, is to say, okay, we have some names that are already defined. So we need some, let's have a look at the compare thing. That's the one I want, and I want to have it, yeah. So I'm going to move this. Oops. Near rel, near the definition of declaration. Okay. So now, so to recapitulate, now that I'm up to date with what I did, my goal is basically in compile rule is to take is to add one thing, and says so right now all the relations are considered to be uninterpreted. That means that the defined relations just don't appear That's not what we want. We really want to give them meaning. And to do this, we're going to add environment.t that returns a elg.expr. So that should type until I need to call something recursively, I suppose. I didn't expect there to be a problem here. Oh, here we are. Okay. The environment is passed, no. And bun value. Didn't I? Oh, sorry, I need another one here. Okay. So here I need an environment. And that actually compiles for some reason. The compile goal will also take an environment. Let's just do it right away. Yep. So we have a couple of unused ones. Actually, that's kind of surprising. I'll have to do the same thing. Okay, so I'm going to make myself a helper function. That's let dref. I'm going to take one of these. And return one of these. Oops. No, I need something more. I need a declaration. That's a literal now. Damn. No, not L. Deckle. Or I for it. Relation. No, that's a terrible name. I'm going to call it D, and I'm good at names. I promise. Sometimes I'm good at names. So what we want to do here, we're going to make an assumption. And the assumption is that either relation is an instance relation, or it's defined in the environment. It means that we can do try and dot find. Oh, sorry, what's the type of find? Okay, let's put the arguments in the same order. The env with not found Vardy. Does that make sense? It looks like it makes sense. I'm using the exception route. I never know which is the fastest. So, whether like if there's a faster way to do this. Is there a find default in CCmap? No. There should be. I can't find what. Find all. Maybe it's not as. It should be CCmap, right? I have opened containers, so then I do map.make. That should give me the big one, right? Get all seems to work. Okay. What's the difference between get and find in thingy? Is there a logic to it? I mean, I guess there is, but no, but there's a get and a find, and get looks like it's fine. Like if I do env.get, I got that type, and it looks a lot like find default. Find opt. Oh, I see. Okay. Get for the total versions, I guess, rather than save. Right. Right, I see. Yeah, okay. It's because of they. So now we replace var with the ref. Stop doing this. Well, I guess it's fine. But I suppose I call it defer. That's fantastic. And I should just leave it this way. Okay, and now this one is unused, but I have a var here too. So I can do the ref. Ref lroot and well, that is great. That doesn't like. I don't like this. Okay. Okay. So we're not completely done. This returns a binding list. What's a binding? Oh. Why do I have bindings? I want this one. Okay. Can I? I don't remember what this. Oh, in a bolt find symbol. Fantastic. Prog. Oh, bindings. A binding list. Okay. We're going to see that the binding list and an environment, like I just did, is the same thing. Do I ever generate a prog? Probably not. Why did I want to do this? I'm not sure that's what I want. Able to find symbol. Right. Okay, so we're going to make a bit of a difference here. In the compile thing, I'm going to generate an environment So we're going to do, oops, expr m.t. Now, of course, this is not going to work. I think that maybe what I wanted to do is to define these relations maybe for sharing. So I wanted to define a new relation for each iteration, but I can do that later. Maybe it was already a bit of like instead of having like one big fixed point, I wanted to define R1, R2, R blah 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 as many number of times as I needed. But I think I just flattened them silly anyway, so what difference does this make? By the way, for those who were there in the first two things, I said, yeah, I can just, like, I wondered why Codecod didn't use BDDs as their formula intermediate form. And it's sort of obvious. Because if you have a BDD at the end, you'll generate the entire compilation of your problem. So it's you have at least sat in O of 1. It's much harder to build a BDD than to build the SAT, and you end up doing this. It's not small BDDs at all. So I was not paying attention, obviously. So here, yeah, we have a list of rules, and do we have of list, okay. So we could do this. We remove okay. It's a bit weird. I only need this. Interesting. That is weird indentation. Okay, this is very readable code. I promise. Totally commit that to your work. Your colleagues will like you. So, so we're going to rewrite that to have to be an under function like this. Because that's precisely what we want. Well, sort of. So now we've arranged the compilation of rules to tell me, oh, it's a function from an environment to an environment. This function is not increasing, so we can make the increasing function. How do we call this? Yes. I don't remember why is there. It just happens to be, okay? Like, I'm sure it made perfect sense at the time. Oh, I see. Okay. Yes. The rules whose head is a given symbol. So we just arrange them to be not empty. Yeah, does that make sense? It's quite possible to use a non-empty type list, but I don't really care. That's I think it's just because right, we have this group by thing that goes on, and group by will give us non-empty lists. I guess you designed it like this, right? So, are you complaining still? Let's go for a very terrible name. Oops, sorry, not Haskell. Should be the case that, sorry. Yeah. Yeah, I mean, it shouldn't be able to give you an empty list. It doesn't make sense. CC, it's not that stupid and unreadable code. And no, I don't actually commit code like this to professional code bases. So, want to take a union. So we're going to have something here. I don't remember what the symbol is. It may be question mark, I'm not exactly sure. And we want to have compile rules of rs_env and env. So really they define the same symbols. They should. Well, you know. And here we just want to do unions. So we can ignore the declaration, and we have then two exprs. So E prime and E. And we want to do regalg.union of E prime E, I think. I need to do a sum. Oh, it doesn't. Okay, I can't do that. Oops. I forgot that constructors were syntactic in OCaml for a second. Okay, so what we just do here is we say at each step. So we imagine that in this environment here, we have the previous value of R at one iteration less. And we're doing one more iteration. At the next step, we apply all rules which give us new values, and we add them up inside the original values, which is given by this and. So that's the original values. These are the new values, and we just union them. That's all. So now this, like if I have a rule list, Rs, if I have an Rs like this, then compile and inflate rules of Rs is a monotonous function. It's an increasing function. And therefore, it has a fixed point. Because we are in a Boolean algebra, it has like it's a finite height Boolean algebra. Because we have finitely many symbols. Like in general, anyway, it has a fixed point, but that might require infinitely many iterations. But we have finitely many symbols, so we can bound the number of iterations at 2 to the number of symbols, which we are definitely not going to do because it's way too long. But what we can do is we know that to reach a fixed point, like we have n rules. And let me think. No, wait. I'm getting confused. I thought I knew the bound. There's a bound that is way better than 2 to the n. I forgot what it is. So let's suppose well, I didn't even know what I said 2 to the n, but I didn't. Yeah. So like let's suppose for a second that each relation is a predicate. It has a single. It holds it's a set of symbol. Then we know that the height is bounded by the number of relations times n. So we have to add at least one n in each of these things, n being the number of symbols. I thought I had a bound in the number of rules, but that may be silly. It can't be. You can have rules that add everything in principle, and so. And really, it's really about this. There's like every step needs to add a tuple in one of the relations, or it's a fixed point. So it's the number of tuple per relation summed over each relation. So we're gonna have to compute this, and we can compute this by seeing what's missing. Fantastic. In a program. So we can like let get derived takes a program. I think it's prog, yeah. It returns, say, a list. We don't really care of declarations. It should probably be a sec, but it's whatever. And the way we do that is we're going to do let get these of a rule. This is going to be very, very slow. Let's do it in continuation passing style. So I'm going to call it add these. That's an accumulator, really. And so that is r dot head.root colon what do I have? Map something on r.rhs. So it's a list of literals. So map fun x, well, L to L.root. At ACC. Okay. So now we can do this, and now we have a bunch of instances. We want to do prog dot rules, and we want to do list.map. Do we want to do list.map? We want to do list.fold. Which fold? Yes, full left is fine. In which case we want to do, that's easier. So that's just written in a way so that full left is convenient. Add these. What's the type of full left? Empty list. Is unhappy. Declaration.rule list.declaration list. Oh, I thought I would be clever, eh? Still unhappy. Yeah, because that doesn't have the right type. Unbound value prog. Oh. It does have the right type, but it's not the right thing because I want to do. This is so slow. I mean, it's all list.mem. Not this.mem. Sorry, I'm confused about that's the equality. I can leave it as it is. The list is prog.instances. Instance, bolded instance. And okay. So these are all the derived symbols. Fantastic. So when we have this, when we have this, what? When we have this, we can count the derived, or we can count the height first. So let that is height. Prog. So it's depending on the prog because it's we're only iterating on the relations that are derived. And that gives me an int. And the way we do this is we're going to do a sum. We don't have sum, really? No. Okay. So we're going to do full left, 0. So that's the sum. We're going to do prog get derived. So we need something here. It has some type. Since 4.0.1. What do we want to do? We want to. Oh, we need the number of atoms. I'm going to add it to prog. Type atom equals var. Oh yeah, we have atoms. Right. So now for each relation, we can do get decol height, which we're going to define here. It takes a derived, no, not derived, a declaration, and returns an int equals and d in d dot what do I want? D dot arity multiplied by prog dot atoms. Oh, length. Is that? Yes, this I wrote the thing with the best performance. Like, of course, all of this should not be lists, and it should really be sequences. That would work much better. It's not too hard to fix later. So now I also need an initial, let's empty env, or let's call it like bottom env. That takes a prog, and that returns a rel alg expr env t, and that's all. And prog, and so we also start with the derived, get derived. But here we are going to map from D to, we want a pair of D and rel.expr. So let's have a look at this definition. I want bottom. I don't have bottom yet, right? I can just jump there. Adding bottom means that I need to be a tad careful. Because it has to be I'm going to have a ton of errors. I'm going to finish this and then fix the other one. So we do relalg.bottom, and we need a arity, and the arity is the .arity. That's list.map, and we finally need to do an emp.ofList here. Why is it unhappy? Let me just click here. Have the full error message. This expression has type prog declaration t, but yeah, that's a good point. Why did I write prog.rules here? Okay. Okay. And so up to some details, we can do then let compile. I need this as well. Let compile prog. For now, I'm going to lie a little. Well, we'll see. So we do, we want a prog, and we return a relalg prog. And I don't think I need this. So we have what? Instance, I suppose? No? Oops, this one. Relalg.instance is defined as prog.instance. It's the same, really? That's not very common. OCaml, let's not do this. And then we have to define the, how was it called? Conster for constraint. The constraint is equals to compile goal. Oh, the literal list is here. Why do I use it? Oh yeah, that's the goal. Okay, no, that's okay. Compile goal, prog.goal, and we need an environment, and the environment is obtained by iterating. Do I have a fun dot iterate? That is height of the program, and the function I'm iterating is compile and inflate rules of prog.rules. And I need an initial value, I guess. right, and that initial value is going to, I don't know why there's an extra line here. It does weird things. Ooh. So what do we do here? What do we do here? We do the empty thingy. So that's 0. How do I call it? Bottom env. What bottom env of prog. Nice. So this I claim is a complete program. And there's really no sharing here. I was considering introducing sharing with names, but I think it's a bit silly. We want to do all the sharing at the term level using hash consing. I'm not sure exactly how I would do that. So they in Codecon, they have this very weird scheme where you don't necessarily, not everything is hash const, and then you have this explicit sharing, but like 2 levels deep, and I have no idea why they do this. But we can do more sharing and try to compile things exactly once, but we can do that later. It's fine. So this module apparently is less than 400 lines long, and we did compile quite a bit. I think I don't have a compilation of so let me so someone has question, is the right time? Oh yeah. I need to do bottom. Do I have a single warning? Yeah, I have a single warning. Sadvar formula T, rel.t. That's the one, right? Yeah. Rel.t. Ooh, that is violent. I want rel. No? Okay. I just jump inside the sources of containers. Our module rel is here. So right. This is a matrix represented as a map on a list of atoms. Like the lists are supposed to have fixed length. But in that case, it's a very easy one. I don't actually need the arity in bottom right now, at least. The solution is quite easy. That's just rel.empty. Boom. So I don't need the arity, yes. Okay, so right now I'm on the arity symbol. It says it has type sadvar, which I guess it is because everything gets type int in that module. And it says it returns a list of all bindings of the given map. And that is particularly delightful. I don't know where he pulled the doc info. That's hilarious. Like, just for this, yeah, I'm gonna screenshot this actually. Here, I've got a screenshot. I can keep this. Look at the box on the top right that says that arity returns the list. Like arity is an integer, like everything is an integer, so it says it's a sadvar type, but it also says that it returns the list of all bindings of the given map. And I'm not sure where it pulled that doc info from, but I just screenshotted this because it's too funny not to share. It's nothing serious, and I mean, OCaml LSP server works fantastic. So I'm not laughing at anybody. I'm just being very, very amused at seeing that this variable here is available since the version 3.12 from OCaml. It's just very funny to me. But you know that many things are very funny to me. So there's that. So let me I pushed before that, so it's okay. A compilation of bottom. Okay. So now we can compile an expert, compile the formula, item list. Yes. Okay. What is the env? Do I even use it? I guess I do. Yeah, that's not helpful. Oh yeah. Yeah, of course. You need to give values. These are the initial values for the relations. They're not going to be very interesting right now because everything is possible. You need to give them ranges or types or things like this that restrict which tuple can be part of the relation, and then you start with a very small thing. the general idea is that you take a program. So this rule also requires the atoms. And you're going to turn all this into a single formula. It's a formula where like the declaration correspond to that many variables, like for each tuple, is it in or not, and then you make a formula of that. So one thing that is a bit sad is in code they have this special case that they use to handle like matrix exponentiation, basically transitive closure of relations, because because it's an exponentiation. Exponentiation is an iteration of an associative operation, and so they make it faster. That's really quite neat. Like it, you have logarithmically many iterations, so it's quite a significant gain in the number of iteration. But here, I don't think I have any other choice than just iterating sillily, and my bound is extremely loose. Like it's extremely unlikely that I need to iterate that many times, but there's no real way to detect this. Maybe by being a bit clever and looking at like making smaller expressions, using smart constructor for unions and etc. to manage the size of things. But at any rate, I have to do all these iterations. Not that it matters too much, like even if I have 1,000 items and I have like a couple of I did something stupid, I think. Height is wrong. That's a silly number. There's if I have a triple, there's more than 3 times the number of atoms. It's 3. Let's open the go, we can do met e bang camel pervasives great. Okay. Camel.org. I think I might have killed my browser. Well, not entirely, apparently. Oops. But does camel.org exist? I can't open it. Like, I don't know, open. That opens. Okay. I don't remember where things are. What's the exponential function? Is it the, yeah, I want the exponential function, yeah. Right. In .pow. Fair. Which one is which? First pow the second. Okay. No, the one on integers. Great. Yeah, so if I have triples and n atoms, I have n to the 3 n cubed atom possible tuples. That makes sense. But even then, you need a lot of tuples before that becomes a problem compared to iterating. Maybe it is a problem. I don't know. Like if I have 1,000 atoms and I need to cube that, then I end up with 1 billion iterations. Yeah. There may be a better way. But we don't want to detect equality because it's never gonna really work. So there. It may be a terrible way to do what I'm trying to do, but it's kind of fun. Yeah, I don't know. I think about it. For the time being, this is a bound. It's not the worst bound, but it's a big bound. Well, it can be. So in regular LTTP, there are 200 things. Well, 200 places. And then there are they're like, we can say there's 400 atoms, give or take, and you have a quadratic thing, so 400 times 400 is less than 1 million. It's like it's 200,000 or something like this. I can ask Emacs. That's not the command. I can do times 400. That is, yeah, less than 200,000. That's what I thought. It's in the bottom left of the screen, like over there. So what we would want now, I guess, is to be able to take a... There's something that doesn't compile. Why are you unhappy? Oh, atoms. That is quite true. So we could lower to sat, but I'm going to leave that for another time. What I can do now is to try and see. We have something else. Where did I define my programs? That was the multiplicity translation. I'm going to ignore this. Wow, I worked hard on this. Like there's almost like just adding the multiplicity is almost as long as doing this last 400 lines long, and this is 350 lines long. It's also better programmed than my other thing on the left. The way I'm going to do multiplicity here is not by doing a translation like this. I think I'm pretty sure I can ignore this and altogether. So this use the minisat plus trick. And that is that when you say, oh, I need 7 of these, I have several identical things, so I need 7 of these, then it will just create a quasi-Boolean equation and translate it back to sat. What I want to do for the relations, though, is to say, when I have these things, but I'm not entirely sure actually. I want to say, oh, I've got atom, like I got copies of atoms, and then I do some. Maybe I'll actually end up doing the same and compiling the relations to quasi Boolean clauses instead of formulas. But I'm not sure. I'll have to think about it. That being said, the general idea is the same except like we have we need some tiebreakers. We need to avoid, because we count models. So what we can't have is saying if I have 2 copies of A's and I put like I don't know, 2 swords, and the swords are identical, but they just appear as 2 different atoms, and so we can't really have sword 1 in chest 1 and sword 2 in chest 2 being a different shuffle than sword 1 in chest 2 and sword 2 in chest 1. So in that particular version, I think I just order them, and I have some ad hoc constraint that things are well ordered. Like there's when there's an item in chest, like in chest one with a sword in chest 1 and a sword in chest 2, then the sword in chest 2 must be bigger than the sword in chest 1. And that's fairly ad hoc for this particular use case. And the prologue version can't really express these sort of things, but what we can do is take the symmetry breaker that Cod does, and I have completely forgotten how it works. But we can use the symmetry breaking as a way to say, yeah, we have only one of these models as a legal model, and that will do the same. So the sort of the inputs of the symmetry breaker is a bunch of atoms that are considered to be symmetric, and so we, in that particular case, we define them so we know exactly which one we want, and then boom. I don't remember exactly what rules are added, but it's not particularly like it was hard to figure out because it's very implicit, because I guess like everybody that reads that already knows what it is, but I don't. That's fine. Yes, I'm stalling, but I'm really, what I'm looking for is the definition of a program, which I'm guessing is in main. Compile arg, module phase. I don't remember what I did. Let's have a look at what compile arg is. Let's open LSP here. Oh, it's not happy about something. Open data log and bound module data log. No, it's not. Is it? Looks pretty. Can I go there? Oops. unused open dialog, but it's not, it's there, that's for sure. Let's try again. Yes. That looks better. Maybe it wasn't built. I don't remember if I'd built it before. Maybe I cleaned it actually. About the program. Let's say so. Compile arg takes a program as an argument. Yeah, so I use a queer functor thing to chain the phases together. Phases.make. I need to see this. I forgot what I did. I have this phases thing. New problem into some solution to new problem solution to the original problem. Okay. Oh my god. When I refactor this, I'm going to spend days. This is so ugly. I have no idea where this module exists. So here I take a module that just contains a program. Whatever a program is, I can have a look. And then I define a bunch of things like the indexed items, which is a list. So here I'm saying these are sequences in the sense of the standard library, instead of items, but it's fine. I take a pool in the programs. The pool is the items that are available, and oh yeah, and I add them. Oh, okay, so that just takes the program, and that creates all the atoms by multiplying the items by the number of occurrences that they have. Okay, I can ignore that in the first step. Maybe. And then there's something about literal with multiplicity. There's time literals, which is not very relevant to me. Dear Lord, what have I done? This is all very, very, you know, wibbly wobbly sort of stuff. It's all mixed up together. So that's all in this one module. So this one is this one. That's the module, and you open a new module, and somewhere. Oh, that's the entire module. What the hell is this? Oh, I see, I think. These are all the phases implemented. That is so weird. Because at the end, this is a mess. Where do I use the pass composition? I don't. That's fantastic. What have I done? This makes no sense. Do I use it in main? Oh yeah, I do actually. Look, there's a pipeline. Okay, so convert provable is the two provable, etc. They're all things. Right, so the phases are somewhat... Okay. So the phases are somewhat monomorphic. So I have to sort of say, oh, given a program P, just make me all the phases specialize with that program P. That sounds very, very fishy. Because it means that they can really only be used in one direction. Or maybe they're not that monomorphic. Let's have a look at convert provable. Let's just look at where it is. Convert provable. Right. Okay. So it is very. It is an A. So it's a pass. It has passes have 4 arguments. Let's have a look. Visit tags. Oh, LSP is not open. What? I'm sorry. How does that make sense? That's so funny. So that's my initial problem. That is my initial problem. So I take a program of a certain form. Maybe that's not the best one. How do I convert it to an arbitrary A? That's a very weird type. They all have this very weird type, like convert to something silly. Prove.convert. They kind of wrap things. Let's look at the other passes. The join observable. I don't understand what I did. Why are these A's? All A. Oh, sorry. Oh, no, that makes sense. That's okay. I misread. So that's my original form and that's my final form. Right, it says if like it doesn't actually do the way back. That's what it does. And these are kind of weird. They're all very weird. It feels like the type means that the notion of pass is not the right one. I kind of have to think about this a bit more. Because all of them, they just say, oh, well, they just, they don't fix the solution up. It's just the solution is the solution. This is no good. I don't think it's going to be the case for us because we have, we can express things. But I also think that we want something a bit more complex than just, we want a type of problem and a type of solution. I think I want to have a state and to be able to pass manually clauses. I've been thinking about that in the last few days, but I never really, well, I haven't been programming for like half an hour, so let's try and find something to do. So, the thing is, the type program is written somewhere here. So here's type programs. I can go and see the definition of program, which is in types. Oh, that's fair. So I can actually inherit from types here. Let's have a little look around. So a program has a pool. You can ignore this in the first step, or we're going to progressively transform a program into a data log program. And we don't actually have the multiplicity yet. Oh yeah, we do. Actually, I think that this is already done. I'm pretty sure this is done. Obsolete command, obsolete command. Okay. So let interp rando program. So that's this is there's an intermediate step. I'm going to write this. This is an intermediate step where the notion of program stays same as pre-data log, so that we can debug. But the spirit is that we can have clauses. No, we can have we will generate. No, we will define more general programs where the instance clauses are not clauses, instance relations are defined in the text. So that takes a times a program and returns a prog equals p okay. So here the program will require atoms it will require it will require instances, and it requires rules. No, it's not happy because that's because it's not instance as instance. Yes, now I have a bunch of unbound value. That makes sense. Oh. Yeah, have a good evening, I guess. See you around. Have fun. So we'll do atoms first because it's boring. Let looks equal here locations. So we're going to do a list.map I. There's no map I. Really? Oh, map I without an underscore. Okay. And we have fun IL to L. Sorry, fun IL to pair IL. So I want numlocks was list.length locks. It's almost midnight and I'm starting to remember how to program in OCaml. Items equal list.mapi fun I it underscore x66. We are ignoring multiplicity. And we want to pair I. Actually, I think I want that direction here too. P dot pool in. So now we are going to do atoms. No, actually, I want this to be not I, but numlocks plus I. So that the items don't, we have atoms for this and for this. I think in an ideal world, we would have things to be typed and locations and items would just not mixed with one another. In that case, instead, it kind of makes a big difference because we move from 400 squared to 200 squared, which, is 4 times fewer. And things like this, or sort of iteration top thingy. I didn't explain earlier why we have to sum across relations. It's just because one relation will get one tuple each iteration, at least one. Otherwise, we're done. It's still a large amount of iterations. That may take a while to be the formula. I don't really know. That's curious. I don't really know. I've been working under the assumption that we don't need that many iterations, and I think that in the I iterated once per rule previously, because they had a certain form, and I knew that each rule would make progress at most once. I think, yeah. And because of this, but we don't have this luxury, and I don't really know. Like bounding this is really the thing that's going to be important. Atoms is going to be list map locks. List map second locks at list map second items. That's wrong. 6 errors in. Okay, that was the problem. 6 English expressions. Something is happening. I don't know what that is. No definition for atoms. Oh, that's a problem. Yeah, it exists. Atom lists. Oh, atoms are strings. So maybe I did that for no reason. Let's have a look at this. Okay, these are strings. Haha. Okay, so this is pointless. So we can I think we can just remove this and says these are p.dot location map first. Oh yeah, I forgot to okay, p.dot locations map first p.dot pool. I just noticed that I have a pool in the P, and I found that hilarious. It's midnight here. Kids are sleeping. I hope nobody is, no kid is watching from from another time zone. That will probably be the worst pun tonight. Despite the fact that we still have like an hour or so of time in front of us, and it's very, very late. Oh, still here. Okay. So that works, I think. And bound value rules and bound value instance. Some fields are undefined goal. Let's just do instance equal fail with instance in. I'm going to define them one at a time, but I want to stop the program from rules fail with rules. Oh, it's still complaining because of. Oh no, it's fine. Maybe. I think it's complaining. No? Okay. It's not telling me, oh, this part of the program is unreachable because you haven't failed with before. It's fine. I was a bit scared about that. I didn't want to have all these warnings. So instance. Instance is interesting because we get to define it by a hand. And it's not part of the program. So let's define this actually. So in it kind of shows up already in the definition of the program because we define clauses for have and for what if I look for have colon? Well, we suppose they exist, really. we have and reach, which are the things that matter. Oh, have reach, and I don't know what. Oh, sorry, have. I don't care. Have is defined. Reach is defined. The one we care about is assigned. So that's the one. So we actually have a single thing here, which is not what I thought. Instance says it's list of one element and the root equals belongs and the arity semicolon is 2. It's not happy because reason. The record field arity belongs to type declaration. Okay, that's because declaration doesn't have the type I think it does. It's named and not root. Okay. Here we go. That's our instance. That's what we want to deal with. Then rules. They have type clause. T, there's a multiplied item, empty atom. I don't remember why we have an MTT here. Where is that defined for starters? So that's mine. I don't remember why I needed this, but I needed it apparently. Gonna have a look where atom is defined, I guess. I is assign. Right. Right. The point is I have an item and I reach a location. And it's mediated by the definition of have, which we can which we'll define here in a nested fashion. So let have def. Definition here that is implicit is that is going to be a rule. Let's have a look. I'm in the wrong. I am very slow. I'm sorry. Here is a rule. So here we're defining a rule. So the head of the rule is have. It's kind of weird because I have this concrete syntax and then I'm lowering everything because I'm losing the types. Yeah. I will want to have some typing, so the arity will propose some typing, etc. Well, we can do this. It's not very hard. It's just a bit time consuming. So head is no, it's not have because it's let me define my predicates. Let assigned equals. Otherwise, there will be a lot of repetition. Let have equals. That's a one arity thing. Let me add a bit of spacing, and we'll call it have. Let reach. It's an arity one thing. Okay. So head equals. That's not sufficient. I want a rule. The head is a literal, and a literal is. That's where we have root. Fantastic. Root equal have and arguments equals a variable. It's just a name. It doesn't matter what it is. Like it's a number, but it's really a name. It could be X. I think, oh, they're names actually, so I take it back. So var X. And so that's the thingy, and the RHS equals so the RHS says well, it's good that we're doing that tonight because it's a bit boring to be honest, but like there are going to be more active things to do next time. So what I want to write. What I want to write, by the way, I'm gonna write it in syntax here. I want to say have X if like if X if X is in L and reach L. That's what we're writing. So here we want to say this is the list. So here the root is assigned. And let me check. Assign is the location first. Oh, it didn't complain. This is supposed to be a list. And so we have two things. We have var L right, and that's one member. Oh, that's semicolon again. And here, L, and that is reach. Let me okay. So that is very much my workhorse. That is the function that is missing. This is the only function in the program where very interesting what we did. It's the only function in the program. It's the only rule, sorry, in the program where there are variables. The rest is pure atoms. But I didn't have the ability to express variables before, and that's why this was entirely implicit. The fact that I need only one is probably just coincidence. Yeah. I just have to translate rules. The thing is, I have my atoms, so yes, they're there. Okay. So I just assume so now we have a bunch. We have a clause, so we can a goal. Sorry, so we can start defining this. So it's an atom. And clauses are made of atoms, yeah? So we can let interp atom equals, so it takes the type dot term dot t applied item dot t mt dot t. I need I said typed. Great. Equals an A. Now we are going to do A and we are oh yeah, sorry. Actions. Okay. So assign. So we don't have any assign right now, I think. We can have a look. T, right, that's empty. Let me do something. I had to spend quite a bit of time cleaning this up, but some places are really awful. So as nothing, and we just do empty.absurd.nothing. That's solve this one. Hey David, how are you doing? So reach, that's the location, I think. There's a draft. Sure. Yeah, so I've got some definitions. So I'm coding here at the bottom. Here I have a definition here at the top. I've got a couple of definitions, these ones that I needed. And here on the right, sorry, I have a bunch more definitions that I'm navigating. I'm looking for atom, by the way, right now. I don't really, well, actually I need this one, I think. Oh yeah, makes sense. So this, well, this is the location, so we're fine. We do, so root as equal reach, and arguments equal atom of L. So that's type literal, and I expected something of type atom. Yeah, that's because I mean something different. That's supposed to be literal. And so this is so this is an item and a number. Ignoring the multiplicity, or the index in that case. And have. Okay. So we can do goal directly by saying the goal is interpatum of p.goal. Let me see if that works. It's supposed to be a literal list. That is fine. And finally, which rules? We're going to map on a list.map. This is going to be p.clauses. It isn't. p.logic. I'm going to make an interpol rule here. Which I'm going to define here. Let interp clause equals alpha and C in. And so we're defining a rule. So head equal inter atom c dot goal. No, not c dot goal. I didn't give the type, so now it's not managing, but I'm too lazy. So I just want to see this. It's actually c dot goal. Maybe I need to write c dot clause dot goal. So that's for the head, and the RHS is list.map inter atom c dot requires. Okay, let's click there. I'm going to no, that's fine. I can deal with this. So program the field requires them belong to. Right. Okay. Have def is not defined, which is, can I close this? Okay, that's because I need to do this. Boom. Now, now I don't know. We're not quite at the point where we can test this yet, and like I don't know what my logics look like. Let me clean this thing a bit, and here we can look at this. So in this one, there's no multiplicity. Now I'm wondering if I actually implemented multiplicity, but I think I did. We'll be able to compare. The one thing I will need to do is to make a real main function that uses some actual arguments. I do find myself having trouble preparing for these days because of, yeah, I'm not often in the mood. I'll be back. So these are ranches. We'll transform them into constraints on the we'll see later. So what do we do next? We may have to also like make this syntax less special eventually. Or maybe we can make it more special. I don't know. I'm scratching my cheek because yeah. I'm not entirely sure where we are going with this next. But basically, here there's a couple of things missing because we don't do multiplicity, but it doesn't matter for this case. We interpret this program of this form into a program of this form. We've ignored the ranges for the time being, but we will have to not do this. then when we have a program like this with this thing, we can interpret it into a relational algebra program, and a relational algebra program we can interpret into a formula. The formula we can interpret into a SAT problem. I think I already have everything I need for this somewhere. I don't exactly know where though. It may be in formula, but it may not be. The formula is very simple, so I don't know exactly where we do this. SAT maybe. I'm generating CNFs. I don't know why. There's several things called formula, of course. Okay. Maybe I should just look for Satan. What is A? Oops. Okay, that's the type of literals. Okay, I do that from a BDD rather than doing that from a formula, but that's fine. I need a break. Give me a second. I'll be back in a sec. I'm back. So I'm trying to think about what we are gonna do next. That's not completely clear to me. What is the next step? Like lowering into SAD is not too hard now, I think. But tying the knot is a bit difficult, and I need several. Gosh, I wonder. I kind of think that the next step is to make. So let me. Just open DuckDuckGo. Oh, Nope. So documentation. So command line is the most common way to make an actual program in like an actual command line parser in Camel. And it takes a short while to get your head around it. So I won't be able to do that tonight because I need to page in the documentation. It's pretty late already. You know what we can do? So yeah, anyway, I want to be able to do this because then I will be able to have several paths throughout my program. One to use the data log translation, the other one using the traditional translation. I will start to be able to do a number of things, and we can start debugging pretty much. Yeah, I think that's sort of the natural next step. I also want to actually plug the thing onto SAT, but I may be able to do this in a very simple way, so I can avoid the whole phase story, which is the phase I find are not great. I can improve on this thing. Something we can do though is starting to do something that I didn't end up doing. So camel. So what do I have here? So I think what do I do for a camel? Like, let's have a look at Haskell. I have some things about it, right? Use package Haskell mode. No, that's just, there's no special LSP package for a camel. Let's have a look. So this is all use OpenSwitch lookup or camel Merlin binary. This is completely irrelevant now. I can yeah, okay. Comment. That will disappear, I suppose. It's pretty. It's a lot of a mess. So the OCaml language with it's quite a bit out of date, I said. There's not even no CP indent. Maybe I'll configure. I'll see how to configure OCP indent again. Or maybe it works that way. The OCaml language with. Let me just a web page for this. Then look at the shell next. Put the camel SP server. Okay. But I'm doing something off screen just because I'm looking for an address and I'm not very comfortable with the thingy. That is cool. No, wait. All right, okay. So with Control L, so that's the address, OCaml LSP server. How are we going to do this? Yes. So what do we want to do? So package list packages. Ellie, what are we supposed to do? Are we supposed to have the wiki, is it empty? It looks pretty empty. I'm not there actually. So do I want to install? Actually, what? Oh, that's Tuareg, right? I remember that. That's OCaml. Let's look at whatever's OCaml here. Code editing common for Emacs. I don't know if I'm supposed to use, which one I'm supposed to use really. I think I use Tuareg, okay. Okay, so I'm gonna do use package. Use package. Tuareg. Haskell, did I do the no? So yes, that's what, oh dear. Oh, it's actually worked, okay. What I want to see, I want I want to say Emacs. Emacs LSP mode. Okay. So we're having a bit of a detour here just because it's late and I don't really have time to program anything. So I'm just configuring my Emacs to open LSP on OCaml. So I'm refreshing. So you can see. Okay, I killed my thing, I think. Here I did everything with manual installation of everything. It's a very old thing that I wrote before Melpa was even a thing. Or maybe like package was maybe not even a thing at the time. So that's Emacs. That's like that's you know a geological layer in my Emacs thing. So let's fix this. Of course, I just killed. I did kill it. Okay. History. LSP. That's the one. Okay, back we are. Languages. On the left, you can find supported languages. Really? Okay, now I have everything. So where is my OCaml? It's here. Yeah. No, that's not what I wanted to see. Okay, well, I don't really have any data, so let's figure it out. Init. Apparently config is better. I'm wondering if there's a hook command as well. Right, I think it's you can see it on the left. I believe it's a hook. We can do this, then Tuareg. And we do LSP, I think. I want to oh my, what happened? Interesting. I'm a bit worried about this. Let's leave this here. Okay. Tuareg. Let's Tuareg mode. Okay. So what happens if I do this? That is very much what I didn't expect to read. no, XP. Okay. If I do revert, now it worked. So if I open something I hadn't opened today, ZDD. Oh yeah. So that's actually pretty simple. We can't see it on the left, but if I go to my OCaml thing, then there's really little left. Okay. And so that's the entire configuration. It's simpler. That being said, oops, something weird is happening. To do, I don't know how I did this. To do, should I add an indenter? Like, I'm not too interested in OCaml format and things like this because because they're like quite a bit too opinionated. Actually, they sort of contributed to what was happening. I know exactly what's happened in. Do I have a camel format actually in my dependencies? Like by mistake. Shell. I have a CP indent, but I don't use it. Or maybe I use it. But something was breaking my lines for some reason. I don't know why. Okay then. So here is a very simple thingy for OCaml. It requires you to have LSP mode somewhere. So let's have a look. Where do I have LSP mode? Here we are. Oh yeah, that's at the top. So LSP is a bit difficult to configure. So yeah, you can definitely have a look at my dot files on GitHub if you want to see more. I don't use all of this, but some. So what's really useful is like all these parts. So that implements the breadcrumbs that Dascube was phoning over at the beginning. That's okay. That's my stuff. It doesn't matter for you. That's my setup with Boon. And here are the things that happen. So so that matters. That's because of Boon. That's to have the breadcrumbs and so on and so forth, or any other things we want. And yeah, you need one of these, and that's for Boon. You want to add this and possibly something for Helm, though it yeah. So I think if I do like search for symbol, then I have a Helm thing here happening. That being said, it's not working on OCaml. Treemax, I can show it off maybe. So like LSP treemax, I think I need to type symbols. Well, there's not. Okay, so here we go. We can have this sort of navigation table on the there's some stuff to set up it doesn't work. I don't know why. I need to double click. Okay, so that's you can see I can that's the param module. There's the val module. It's really a module type. You can see all of these things being defined. So get a nice summary of the menu. So it's kind of nice if you like this sort of things. I don't really work with one of these, so it's just here when I want one. That sort of gives very much the VS Code experience though. So if you like VS Code and a bit like and you know and a bit jealous, but Emacs is better for you because there isn't Y or Magit. Then that kind of works if that's your kind of thing. It's highly configurable, of course, because it's Emacs, so you can spend as many hours as you wish or years trying to make this more to your convenience. There are other things you can do, like LSPUI, iMenu, which is another thing you can use here to navigate through your things. That's more keyboard oriented. So there's a lot of things you can do. Does that move with me? No, it doesn't. Okay. Can I kill my Tmax? Oh, quit. Okay. I don't know what else you can do with Tmax, like Tmax. It doesn't your projects, and I can use it as a project. The icons are ugly, but I can still use it to navigate my project as a tree. Right, Tmax find tag. I don't know how it works, but yes. So if you like these sort of things, plenty of things are available on Emacs. I'm going just to commit my config. So it's not completely sufficient, but you can do LSP once, and then it's simple to do all of your programs. Okay. Okay, that looks good. I have to check that it doesn't do nonsense, but it's fine. Here you go. I think that's all for tonight. I'll be back next week with some video games. I'll be back in 2 weeks with more on this. Probably I will be working on making the executable a bit more tight and start plugging things together. I'll make a design by then. Yes, so this this is really easy and simple. So it's probably all wrong. We have the problem, like it's all like 400 lines of code, and we have almost everything working-ish, except that we have gigantic bounds on the number of iteration, which might become a problem. I don't know. We'll see. Yes. Yeah, no, I don't have anything else to say. This is really, really easy compared to the other definition. The code is terrible. I'll eventually fix it up, I'm sure. Maybe if I'm brave enough. So yeah. Yeah, so it's probably wrong. No, the thing is, it's not tested, and there's so many things that can go wrong. I don't think it will be hard. What's hard though is going to be to debug it. One of the good thing is that there was some natural ways to look at what was happening. They're not great, but they helped me a ton debugging the code. Yeah, it's going to be mostly comparing with the previous results and see what's and maybe there's a bug in the rest and we won't see it. I don't know. We'll see. It is sort of okay. It would. Yeah, I don't know. I need to think more about this, especially on the bound thing. But we'll see if it looks like it's good. It's not very easy to convince yourself that it's not buggy, so that's kind of the problem. But at any rate, I really like how easy this whole thing is, and there's plenty of complications to do. Like I don't know how to do that, by the way. There's in Cod, they sort of say, oh, if there's a bunch of true in a sequence, we're going to just make one block, and we need to review some of the algorithms based on that to avoid. So if you have a matrix that is full of truths, then it's really, really, really big, and you don't really want that. Like if you, and it's not unlikely to happen, actually. So you want to optimize for this case. The false case is trivial because the matrix is empty because it's a sparse matrix, but the true case is complex because the sparsity cannot really be reversed. And then there's some cleverness to be done there. I don't really know how to do this, but we can do that progressively and do that by abstracting away some things. But this is just an optimization. At any rate, that's going to be all for me. Thanks a lot for having followed along and having had fun with me. And yes, until next time, don't forget to stay curious. Cheers.